All right, so number 40 was actual data. All right, so we have in 1999, the National Oceanographic and Atmospheric Administration, wow, that's a lot of words, reported a total of 16 Atlantic cyclones. So we have 16 cyclones. In 2000, there were 19 cyclones. Find the percent of change in the number of cyclones from 1999 to 2000. Okay, so my percent of change equals, and again, you guys, I have to see the formula every time. Stop doing that, or I'm just taking it away. So just set it aside. It's not your cell phone. Thank you. It's the amount of change divided by the original times 100. All right, so I'm going to do my amount of change. So it's 19 minus 16 divided by, well, I'm starting from 1999 and I'm looking at 2000. So my original is that 16 times 100. Are you cool so far? Okay. So 19 minus 3 or minus 16 is going to be 3. Please show me all the work. Please show me that you're multiplying by 100 in each step, please. All right, so now I have 3 divided by 16 gives me 0.1875. So this is 0.1875. You guys do not drop off parts of these decimals. All right, because you are going to get it wrong. I am expecting you to know how to round properly. I am expecting you to know how to read those answers properly. And the directions were round to the nearest percent. All right, so if I take 0.1875, if I multiply it by 100, I get 18.75%. If I round this to the nearest tenth, I'm rounding to here, that 8, I need to look at the 7, and that's 19%. You can't drop stuff off, you guys. You can't. I mean, I was talking to Ava about this. If you got 0.333, or no, better yet, you got 0.8444 as your decimal, and you just said, I got 0.8, and this was a test score, you just dropped from 84% to an 80%. Do you really want to drop that? Do you really want an 80% when you should have gotten 84%? Or so is there a difference between 84% and 80%? Yeah. You just can't drop parts off. If it says round, then you're using your rounding rules. And if you don't use your rounding rules, I am marking you down. You are old enough to know how to use rounding rules. Do you guys understand? Okay, put this away, get your notes out. To the next section. So today is the 9th, so January 9th. We are moving on to section 4.5. All right, we're going to be talking about probabilities. So we're talking about probability. Okay. We've done probability last year. All right. So when we talk about probabilities, so this should be a review for you. All right. I know we don't do it all the time, but it should come back to you quickly. So probability of an event. What this means is it's the likelihood an event will happen. It's the likelihood an event will happen. Alright, so we need to kind of come up with or talk about some of the terminology that goes with this. So, I'm not huge on vocabulary with you guys memorizing canned vocabulary terms, but there is vocabulary you do need to know in math. When we talk about outcome, outcome means the result of an event. An example of that might be something like we're rolling a dice. So the outcome, it's what you roll. A 1, a 2, a 3, an even number, an odd number. All right, that's what an outcome is. Yes. Yeah, it's like the answer. It's what you get from whatever you're doing. If I have a deck of cards and I'm having you pull a card, it's the outcome is what card you get. Okay? All right. All right. So an event is any outcome. All right, so an event is any outcome. All right, usually it's any, let me expand this. This is any outcome we are looking for. So for example, if I want the probability of rolling an even number on a dice. All right, the event that we're looking for is an even number. So if we're looking to roll an even number on a dice, the event is the even number, because that's what we're looking for. All right, so let's take a look at how all of this makes sense. So if I take a look here, so let's say, I'm just going to kind of expand on this. Let's say our event, E-V-E-V, that totally doesn't look right. That's right. Our event is rolling an even number. We have all possible outcomes. Well, on a dice, what are all the possible outcomes you can get on a dice? Peter? Yep, so 1, 2, 3, 4, 5, and 6. These are all the possible outcomes. So Nick, to get back to what you were asking, an outcome is the result. It's the answer to whatever you're doing. So all the possible outcomes you can get from rolling a dice is a 1 or a 2 or a 3 or a 4. All right, what we talk about are favorable outcomes. Favorable outcomes are the ones that meet your event requirement. So these are the outcomes that meet the event requirement. So in our example, what are my favorable outcomes from all these possible outcomes? Matthew? 2, 4, and 6. All right, so that's kind of what events are. That's what outcomes are. We have all possible outcomes, and we have favorable outcomes. You guys cool so far? All right. we have two different types of probabilities. Who remembers what they're called? Who remembers the two different types? Oh, Nick, you're going to try. Go ahead. Nope, those are my outcomes, but I like that you're trying. All right, how about theoretical? Theoretical probability. That's when we're looking at cards, dice, Scrabble pieces. All right, and the other one is experimental probability. This is when we use actual data, surveys. Today we're going to be talking about theoretical. The formula for both of them is exactly the same. Who needs to see what's up there? Chris? Actual data. Yep, so experimental probability, it's when you're dealing with actual data. Like I could survey people in this room with their favorite candy. All right, and then I could find the probability of, you know, what's the probability if I put everyone's name in a hat with their favorite candy that I pull out a Reese's peanut butter cup, right? If you guys all put in a hat your favorite candy, what's the probability of me pulling that out? All right, that would be experimental. You guys, all of you guys putting your names in a hat to become class representative. All right, that would be experimental because it's actual data and I'm just pulling a name out of a hat. All right, let's talk about theoretical probability. All right, let's talk about theoretical probability. All right, so the way that we write this is probability, P, and then event. That's not multiplication. This is just, if you remember from last year, this is just probability notation. All right, so if I have something like probability of even number, that's how we would write probability of an even number. That's what that says. So this is just probability notation. All right, so probability of an event is equal to the number of favorable outcomes divided by the number of possible outcomes. And we've already talked about what favorable outcomes mean and what possible outcomes mean. So it's your number of favorable over your number of possible. How many of you guys kind of remember this? Awesome. All right, when we talk about probability, we've already kind of talked about, so probability, it's the likelihood an event will happen. All right, so we either see this as a fraction, we can see it as a decimal, or we see it as a percent. These are our possible answer forms. So forms of answer. All right, so if we take a look at the example that we did, we want the probability of rolling an even number on a dice. All right, so it's my number of favorable over my number possible. How many numbers on the dice are even? So my number favorable are the number of even numbers. The possible are the total sides. So how many numbers are even numbers on a dice? Jacob? 3. How many total numbers or sides are there on a dice, Jacob? 6. So my probability is 3 over 6. I want to simplify that. So my probability is 1/2. What does that look like as a decimal? Peter? What? Yep, 0.5 or 0.50. What does that look like as a percentage? Chris? 50%. So, go ahead. So favorable is a number of even numbers. How many even numbers? So the number of favorable are how many of the outcomes meet our qualification. So the number of even numbers. So when I look at what this means, when I look at what half or 50% means, all right, what this means, if I have a number line, I know I didn't ask you guys to get a ruler out, but I wanted you guys to be able to see this. So draw this number line. So we have 0 at this end. This is our likelihood kind of number line. On this end, we have a 1, or a 100%. 0 is 0%. Right in the middle is going to be 0.5, 1/2, or 50%. If I have a 0% chance of something happening, what's the likelihood of that happening? What would you say is how would you explain the likelihood of a 0% chance? Matthew? Yeah, this is not happening at all. Not happen at all. Or impossible. What about 100%? If I get a probability that you're going to have 100% what you want is going to happen, what's the how would you explain that likelihood? Victoria? Yeah, this is going to be for sure. Happen. 50% is your breaking point. Anything bigger than 50% is more likely. Anything less than 50% is less likely. So the smaller the number, the less likely it's going to happen. So that's what the probability means, is a likelihood it's going to happen. So 50% means, well, you got a 50-50 chance. 50% is going to happen, 50% it's not going to happen. All right, let's look at another one. Who needs to see what's up there? Okay. All right, so here's my example. A bowl contains 12 slips of paper. Each with a different name of the month. So a bowl contains 12 slips of paper, each with a different name of a month. I want you to find the probability of selecting a name of a month that starts with the letter J. Alright, so the first thing I want you guys to do, other than writing your givens down, is I need to figure out how many months start with J. Because this is our favorable information. Because that's what we're looking for. So I need to identify that information. So, how many months start with the letter J? Peter? 3. So I have January, February, March, April, May, June, July, August, September, October. So we have 3. So now that we've done that, I want all of you to now find the probability. The easiest way when we're done is to leave it as a fraction. So when in doubt, leave it as a simplified fraction. Unless they tell you how they want to see it. Always start with the formula, by the way. Come on, you guys are all doing this. This information is required for you to figure out what favorable information is. Come on, Chris, can you not see it? Then move up. Okay, you need new glasses, child. Well, then you just said, can you see it? And your answer was no. Well, that means you can't see it. Okay, look it. I'm not solving a problem for you. If you can't see what's on the board, you need to move yourself so you can see it. So I should see probability starts with J equals. I'm going to start with the formula. It's always your number of favorable over your number possible. That's what you're always starting with. Nick, are you writing this down? Really? Because it looks like you're coloring. Can you do what you're supposed to be doing right now, please? Thank you. So Sam, write my fraction for me. 3 over 12, and what does that simplify to? 1/4. This is what I should see from all of them. How many of you guys remember doing this before? All right, are you guys cool with this? You guys cool with this? Okay. I'm going to let you guys stop. All right, make sure you have all this down. All right, make sure that you understand you've got to show that formula every single time you use it. All right, because that's one of the things I'm grading you on tomorrow in your homework.